Have you ever wondered how pilots land their planes safely in poor visibility conditions? This is where the magic of the Instrument Landing System, or ILS, comes into play. ILS is a lifeline for pilots, an essential tool that ensures safe landing even when the runway is hidden in fog, rain, or darkness. This fascinating system is comprised of two main components: the ground-based equipment and the aircraft's onboard receiver. The ground equipment includes the localizer, which provides left-right guidance, and the glide slope antenna, which offers up-down guidance. These signals blend harmoniously to create a virtual pathway in the sky, guiding pilots safely to the ground. But there's more to the ILS than just these components. It also includes the marker beacon, which provides distance information and various approach symbols. Together, they create a comprehensive system that pilots can rely on for a safe landing. Let's delve deeper to understand how each component works in harmony to guide pilots safely to the ground. Scene script. Imagine you're piloting an aircraft descending through thick fog. How do you know you're at the right angle? Enter the glide slope antenna. Now let's explore this critical piece of the instrument landing system puzzle. The glide slope antenna is a ground-based transmitter that emits a signal to provide vertical guidance to aircraft during approach and landing. It's like an invisible guide rail in the sky, helping pilots maintain the correct descent path. Positioned near the runway's approach end, the antenna broadcasts a beam upwards at a precise angle, typically 3 degrees. When aligned with this beam, pilots know they're at the right descent angle. If they deviate, the onboard receiver detects the change and provides an indication, enabling pilots to correct their approach. It's an elegant solution to a complex problem, ensuring safe landings even in poor visibility conditions. Now that we understand the glide slope antenna, what happens when we encounter false glide slopes? As you descend, you might encounter what's known as false glide slopes, but what does that mean? Well, in the world of aviation, false glide slopes are higher than the ideal glide path. They occur due to the interference of the glide slope signal by obstacles such as buildings or terrain. These can be misleading and, if followed, can result in an aircraft flying too high for safe landing. Imagine you're following a path that appears to be leading you straight to the runway, but in reality, it's guiding you above it. Now, that's a situation no pilot wants to be in. So, how can you identify and avoid them? Keen observation and understanding of your instruments is key. If your glide slope indicator shows you're on path, but your altimeter indicates you're too high, you might be on a false glide slope. Remember, always cross-check your instruments and stay vigilant. With the vertical path sorted, let's move on to how pilots maintain the right direction with the localizer. So you're descending at the right angle, but how do you ensure you're heading straight towards the runway? That's where the localizer comes in. The localizer, in a nutshell, is the compass of the instrument landing system. It's the element that provides lateral guidance to the aircraft, ensuring that you're aligned with the runway center line. Think of it as your guiding star leading you straight to the runway, even when visibility is low. But how does it do this? That's where the localizer antenna comes into play. Located at the far end of the runway, it transmits two signals in a cone-shaped pattern. One signal is modulated at 90 Hz, the other at 150 Hz. As you approach the runway, your aircraft's receiver picks up these signals. When you're right in the middle of the runway's approach path, the 90 Hz and the 150 Hz signals balance out. This balance is what your cockpit instruments interpret as being on course. If you drift to the left or right, the balance of the signals changes, and your cockpit instruments will indicate that you're off course. Now, let's imagine you're approaching from the right side of the runway. The 150 Hz signal will be stronger than the 90 Hz one. Your cockpit instruments will pick up on this imbalance and tell you to steer left, back towards the center line. But what happens if you're coming from the left side? Well, the 90 Hz signal will be stronger. Again, your instruments will detect this imbalance and instruct you to steer right, bringing you back on course. It's a beautifully simple, yet incredibly effective system, isn't it? The localizer and localizer antenna work in tandem to ensure you're heading straight towards your destination, no matter the weather conditions or visibility. As we approach the runway, there's another important component to consider: the marker beacon. As we get closer to our destination, we need to know exactly where we are. This is where the marker beacon steps in. The marker beacon, a critical component of the instrument landing system, is like our trusted guide in the sky. It's a transmitter that emits signals vertically, providing pilots with vital information about their distance from the runway. As an aircraft descends, it flies over these beacons, each of which has a distinct identity and purpose. There are typically 3 beacon types: the outer, middle, and inner markers. The outer marker, usually located about 4 to 7 miles from the runway, signals the start of the final approach segment. It's like the doorman who greets you and lets you know you're at the right place. Then we have the middle marker, typically situated about half a mile from the runway. It's like a friend who's cheering you on, letting you know you're almost there. Finally, the inner marker, not always present, but when it is, it's usually located at the decision height, the point where a pilot must decide to land or execute a missed approach. It's the final handshake before you step into the meeting room. Now, these beacons are great, but how do pilots recognize them? That's where approach symbols come in. Approach symbols are the visual and auditory cues that pilots receive in the cockpit when they fly over these markers. The outer marker is represented by a blue light and a series of dashes in Morse code. The middle marker shows an amber light with a combination of dots and dashes. The inner marker, if present, is indicated by a white light and a high-pitched tone. These symbols are like the language of the sky, a way for the aircraft to communicate with the pilot. It's all about understanding these signals and interpreting them correctly. Now, how do pilots interpret these signals? Let's explore ILS indications. So we've got all these signals, but how do pilots interpret them? Welcome to the world of ILS indications. ILS indications are the primary source of information for pilots during an instrument landing system approach. They are displayed on the pilot's flight instruments, providing real-time guidance for both the aircraft's vertical and horizontal position relative to the desired approach path. The first thing to understand is the localizer indication. This is displayed as a vertical needle on the pilot's horizontal situation indicator, or HASI. When the needle is centered, it shows that the aircraft is aligned with the runway's center line. If it drifts to the left, it means the aircraft is veering to the right of the center line, and vice versa. Next up is the glide slope indication. Similar to the localizer, it's displayed as a horizontal needle on the HSI. When the needle is centered, the aircraft is on the correct descent path. If the needle drifts upward, the aircraft is too low and needs to climb to realign with the glide slope. If it drifts downward, the aircraft is too high and needs to descend. But how do pilots use these indications for an ILS approach? It's all about precision and timing. When approaching the runway, pilots use the localizer indication to align the aircraft with the runway centerline. Once aligned, they maintain this position by keeping the localizer needle centered. Simultaneously, they monitor the glide slope indication. As the aircraft approaches the descent path, the glide slope needle begins to move from the bottom towards the center. The pilot then adjusts the aircraft's descent rate to keep the needle centered, ensuring they stay on the correct glide path. By continuously monitoring and adjusting based on these indications, pilots can execute a smooth and precise ILS approach, even in low visibility conditions. Now that we've navigated the complexities of ILS, let's recap what we've learned. Navigating through low visibility conditions is no easy task, but with ILS, pilots have a reliable system to guide them. We've embarked on quite the journey today, delving into the intricate workings of the Instrument Landing System, or ILS. We started with the glide slope antenna, the silent guide that sets the vertical path. Then we navigated the tricky waters of false glide slopes, understanding their potential to mislead. We then turned our attention to the localizer and its antenna, the components that keep us on the straight and narrow, horizontally speaking. We learned about the marker beacon and approach symbols, the signposts along our journey, before ending with the ILS indications and approach, the final steps in our descent. These elements, working together, form the backbone of ILS, a system that's invaluable to pilots worldwide. With a system as sophisticated as ILS, pilots can confidently navigate even the most challenging conditions, ensuring we reach our destinations safely and smoothly.